I'm Sam Edwards. I work for Capital One. We're going to have a booth downstairs. Feel free to come talk to us. We have an office pretty close to here. And I work with this team, although I'm based out of Richmond, Virginia. Like I said, the deal is I wasn't able to post the slides online. But if you follow me on Twitter at HandstandSam and send me a message, I'll send you a video that I'm recording right now of this. This topic is going to be maintainable espresso tests, which is one of these dream things of what does that mean and how do I achieve it. So I'm going to go into all the pieces of what you need to do to achieve that. And part of this is going to be with robots and screenshots. I wasn't going to play this video, but I think it will give a good framing of what we want to achieve out of this. So this is a demo I put together for something internally, but it doesn't have internal stuff in it. It's actually two connected devices here. We have a Nexus 6 and a Nexus 5. We also have 3 emulators running, a tablet-sized emulator, a smaller res device, and another one. But what this is going to show is an espresso test suite running on all these devices at once and generating one report based on that. So here we go. And it, by the way, it flashes too. Just the screen flashes. Just a warning for anybody. So it's setting up to run Spoon, which is going to run everything. And it starts running. This is a little quiz app that kind of just gives random quiz questions about Android and says that it's the best operating system. But it's loading the APK one at a time on these things, so it's a little slower to start on the devices.
Is this real time? Or?
Yeah, so this is double speed. When I did the presentation, I only had so much time. And, yeah. The whole thing is when you pull up a report, it has all 5 devices there listed. So that's kind of like our dream state of where we want to get, and this whole talk is going to kind of try to take us there. All right. So as I said, I'm Sam. Feel free to talk to me anytime during the conference. I love talking about this stuff, but hopefully I cover everything you need to know here. That's the goal. First, I want to picture what this dream espresso test suite looks like. You kind of saw what it looks like when it runs, but what are all the characteristics that makes that up? First of all, you want it to be very easy to write. This is not only by developers, but also by testing engineers, because testing engineers are typically the people that write this kind of stuff. Also, you want it to be low maintenance, so maintainable espresso tests. When something changes in the UI, or you said the product owner comes by and says, we're going to do this whole new redesign, it's going to be similar. You want it to be very easy to update your tests. You want UI tests added during the development lifecycle. Now, these are all like kind of components that I feel like are required for maintainable espresso tests. This is more of something that you're doing within your company and as your processes go, but these are important to having maintainable espresso tests. You want them to be hermetic, deterministic, and targeted. Hermetic meaning that it's cut off completely from all the outside world. It's deterministic meaning that every single time you run it, you'll get the exact same results. And targeted meaning that you're only testing one little piece at a time. Ideally, you'd like your test to be run on every PR in your continuous integration. So every time you make a change in a pull request, it will run the entire test suite and give you back the results. And that way you know, did I break anything during this? And because you might be editing one part of your UI, but then you didn't realize somebody else is using that resource or that color or that layout, and then it breaks their test. So that's super important to get that feedback in order to find these bugs before you actually commit it into your code. You also need a really reliable test execution environment. You'll find that as you try to run tests, like a device might be disconnected or offline. Trying to get hermetic tests, it's hard to have an execution environment where the first test won't affect the second test. So that's important. And finally, the icing on the cake, as I like to call it, is automated screenshots. So in the demo you saw in the beginning, each one of those is actually taking a screenshot while it's running. So you can see on each one of the devices what that looked like, the resulting test. So this is Dorothy from The Wizard of Oz clicking her heels, hoping that she'll go home. So audience poll, I just want to get an idea of where everyone was in the room. So how many people have done testing in any manner? All right, that's good. And then how many people have done espresso? So good. How many people feel like they're really good at espresso? Okay, so that's the hard part, yeah. How many people take screenshots in their espresso tests? Awesome. And how many people use continuous integration? And how many people run all of their tests during continuous integration? That's pretty good. All right, so I'm talking about maintainable espresso tests, but why would you even choose espresso? I want to make sure that I cover that because there's other solutions like Appium and Calabash and other things of that nature. But first of all, it's created by Google, which doesn't mean it's the best, but in this case it is. And the reason is because they write Android and they write this, and this is the solution they use internally. So we know it's well tested and it's going to be the best experience for us. And I'll actually go through more reason there. Also, it has access to the internals of your application. Because it's using the Android instrumentation test runner, it has access to all the internals of your application. So typically if you're using like Appium or Calabash, you're like kind of on the outside just tapping on your app. Or in this case, you can actually mock a lot of the internals and do instrumentation tests in that regard. It's easy to write. The syntax is great. We're going to have some examples right after that. This, just for those people that don't know Espresso. And it's blazing fast. And this is exactly because we have access to the internals of the app. And Espresso knows all about all those. So using Espresso is pretty simple when it comes down to it. There's 3 pieces. First, there's on view. And what this is you have your big box of the screen. And obviously, like if you have an image, it's a box here, and then you have your text layout. But every single thing is a hierarchy of one box inside of another box inside of another box. And a view matcher, what that allows you to do is describe which box you're trying to interact with on the screen. So you can do this with any of the proper. This is a cheat sheet, by the way, on the Espresso website. It's kind of clips out of it, but you can grab this whole thing there. There's with ID, with text, and what this allows you to do is say, I want a view on the screen that has the ID of r.id.username, or that has a text, like login or something of that manner. So this allows you to describe what element you want to grab on the screen. And then secondly, there's 2 things you can do, is you can perform an action on that, or you can do an assertion. So if you want to perform an action, then you can either click on it, you can scroll on it, if it's like a container and you want to do scrolling through, like a photo gallery, or you can actually input text or clear text and do things in that manner. So those are actions you can do. And then if you want to go ahead and do assertions, these are great for saying, is this checkbox enabled? Does it actually show on the screen? And what's really important is to say, does this not show on the screen? Because you have to think of these cases if you have a state where I want to show this, if this is the case, or otherwise make these visibility be gone and show something else, you want to make sure they're actually being hidden. So that's just kind of a trick there. So here's a really simple Espresso example. So in this case, we're looking for a view with the text shopping app. I've kind of highlighted it on the screen there with my excellent red pen. But what we're doing is we're trying to find that one element on the screen, and we want to make sure it's displayed. So super simple, but I want to make sure on this page that the shopping app title is shown. The next thing I want to do is interact with the username field. I know I've given the edit text r.id.username, so I'm able to target that by saying on the view with the ID that I've already have inside of my Android app. And this is another reason why access to the app internals is really nice, right? You have exactly the ID of your app, and if you refactor, that ID stays or changes along with the code that you changed. Finally, and then you went ahead and performed the type text and entered the username Sam. And then here we're going to grab the view with the text login, and on that we want to perform a click. So we grab the element with the on view, we either check it does something or perform an action on it. Espresso is easy, right? They make it that way, but having a maintainable full Espresso test suite requires a lot of things working together. If you haven't done any Espresso yet, absolutely use this. The pros are it's great for beginners. It's completely UI driven. You just launch it in Android Studio and you go to the run section and click record Espresso test and you tap through and you have an Espresso test. It's beautiful because if you don't have Espresso in your app, in the compilation section of your build.gradle, it'll say Android test compile and add everything for you. It'll create the Android test source directory and add all the package structure you need in there. So it's kind of a nice way to just automatically put it in there. The bad news is about Espresso Test Recorder is it really only works on very simple tests. I've done more complex things, and it's not very good at scrolling. It's not good if there are duplicate. Let's say you have like a recycler view, and then you have like an ID of an image, ID image. It doesn't know how to differentiate those very well. So these are more complex cases, but if you're using Espresso Test Recorder, start out with that whole idea of one username, one login button. Go from there and just have your structure of your Espresso test suite. Also, the tool is really slow. I'll talk about why. And you get generated code, which the generated code is really not that bad, but it's still generated code. It's not the end result that you really want, but it's not too bad. So this is actually in some source code that I have. I went ahead, like I said, and went to record Espresso test. So your only prerequisite is you have an application that can build an Android Studio and run there. Once that's set up, then it will go ahead and pop up on your emulator here and say waiting for debugger. And just like it is when you run in debug mode, it will show that screen. But what that means is it's waiting to attach to the debugger port on the Android app. Now you haven't said I wanted to start my app in debug mode, but Espresso Test Recorder did this for you. And it did it because it's actually injecting debug points wherever we're going to perform actions within the UI, whether that's typing text, swiping, clicking on things. And so what it's going to do is do its best job to intercept those events and kind of just figure out, oh, they clicked on a button with this ID or with this text, and automatically handle that for you, which is magical. But it does make your app really slow when it's going along. It looks, when you type text, it's like crawling, like it's pretty annoying. But use this for very basic cases, and then you can get started. In this case, we're getting the screen, finally loaded up, and now we have this like panel of recorded events. What will happen is as you interact with your UI with the actions, being typing, clicking, and so forth, events will start to populate here. And then you can also at any point hit add assertion, which will take a screenshot of the screen and allow you to like, oh, this is the next thing here, allow you to hover over a part like we can over this piece of text, and then we can add an assertion down here saying, for this welcome message, I want to make sure the text is, and it will auto-populate, welcome back, Sam Edwards. So in this test, I know I've actually logged in with the, I've typed in username Sam, password, check remember me, logged in, and now once I'm logged in this test, I want to make sure Sam Edwards is logged in. That's my test. Once you've already used Espresso Test Recorder and you have everything set up, I really like the layout inspector. Has anybody used this before? So what's nice about it is you just go to Tools, Android, Layout Inspector, and it comes up with a little chooser that's similar to like which app do you want to run your phone on, which phone do you want to run your app on? In this case, it has all the devices and then the debuggable applications on those devices. So in this case, I have a handstandsam.shopping app. I go ahead and say I want to use that. And it actually saves this .li file inside of a captures folder in your Android project. And what's nice is that it actually like takes a screenshot of that screen and then the entire UI hierarchy dump. So this is that like the box inside of a box. This is represented in this hierarchy view. And on the right side, in this case, I'm also in the welcome back Sam Edwards text. You can see on the right side under the properties, it says ID welcome message. And if I expand text, it'll actually say welcome back Sam Edwards. So what's really nice is if you're testing a larger flow, you can basically record or capture each one of these screens, and then you know what all your IDs and text are on that page. So when you're writing your test, you don't have to run and then it breaks and run and breaks. You have a good idea of what it is early on. So who should write Espresso tests? I don't know, is anybody here not a developer but a tester? All right, that's great. They say that Espresso is targeted at developers who believe that automated testing is an integral part of the development cycle. Now, this is a quote from their website. While it can be used for black box testing, which is purely like just clicking on the app, Espresso's full power is unlocked by those who are familiar with the code base under test. And the reason this is because you have access to so many internals and you can set up the state yourselves. And what's awesome is if you have testing engineers that do not have the access to these internals, you can set up a testing framework yourself that allows them to write tests on top of it without having to know that. So they can perform their job plus get all the benefits that you're able to get with Espresso. So when should you write an Espresso test? Avoid it. So that's pretty much it. This is the testing pyramid on the right. At the very top, it's a turtle representing very slow tests. On the bottom, a rabbit representing very fast. And then money symbols, fast and, very expensive and then very cheap. So what it's saying is the very tip of this here is a black box test where you're just clicking on the screen and going through things and hitting like a real live server. And that's expensive because it's going to take a lot of time to flow through your entire part of your app, hit your real servers and so forth. And as you go down, you finally get to the unit test, which might do the logic of, did this method get called using Mockito or something like that. And in the middle are just like Android tests that make sure that all the pieces of your application are working together. What I'm really focusing on in this session is this layer right here between service and UI. Because what we're doing is in order to be maintainable Espresso tests, you need to run on mock data, be hermetic, and all these other properties. And we're not wanting to do this tip of the iceberg tests that are just like interacting with our normal servers because there's so many things that can be out of our control. The goal is to test the UI and have everything within our control. Only write an Espresso test when you're only testing the UI. Like you can use Roboelectric if you want to, but if you get in there and you're seeing, is this button still there, or is it enabled or disabled, use Espresso instead. Just use that if you need to do something that doesn't involve the UI that you don't want to run an instrumentation test for. Also small and targeted. So as I mentioned, in order to kind of be at this level, you wanted to specifically test a screen. So you wanted to jump all the way into that settings page of your app and not make the user go through the whole flow and sign up. It's your goal as a developer to set up the state of your application so when they get to that screen, your app allows them in and it doesn't like direct them to the login page like it normally would. How is Espresso fast? So I've claimed it's fast. Before I say how it's fast, I want to give you an example. So in our code, in our test suite, we had an Appium test suite that took about 4 hours for the entire regression to run. And it was very error prone because it hit all of our QA servers that were up half the time or down half the time, or if they weren't, then our test account that we had now had extra data added in we weren't expecting, and so it made this like really hard to deal with. So we did a pilot almost 2 years ago, or a year and a half ago on Espresso that I helped lead, and that's where I got a lot of this data from. And so we actually took this 4-hour test suite and got it under 25 minutes. And this actually ended up covering more, and we still run it on under 15 minutes now. So we're able to do this with Espresso because it's aware of the Android's main thread. And if you're Android developers, you probably know what the main thread is, but it's basically the UI thread that like the user ends up seeing. So whenever you see jank on the screen or whatever, that means you're doing too much work on there. But it's aware of this, so if anything's happening on that main thread, Espresso is just going to wait and chill back. And we'll actually see the process of how Espresso checks things. It's also aware of the async task thread pool. I know everybody here loves async tasks and writes them all the time. We've all moved on to that pretty much, but moved on from that. But the async tasks thread pool is actually used by all of the Android system internals. So if there's any background work happening, Espresso knows about that and will wait for it. One thing you can leverage, which we did as well, is you can actually take that thread pool and you can create an executor service that you can use as part of like OKHTTP or something. So that when you're looking for executors to run on, you actually run on their thread pool. And so that's a trick you can do instead of idling resources. And idling resources. So idling resource should be called a not idling resource because the goal of it is to basically tell Espresso, hey, I'm doing something, or hey, I'm not. So the way I like to do it is, let's say you had a flagger there because you have a 1-lane road and it's getting construction, or 2 lanes, but it's down to 1 lane. So you can only go 1 way at a time. So if you were doing this in a very outside way, you could say, well, it's safe if somebody goes every minute, right? So I'm just going to say, stop sign, and then every minute I'll say go. And most of the time that's going to be fine. Everybody's going to be safe. But it would be a lot more efficient if you actually had somebody that was watching everything. Everything was clear, and you said, yep, go ahead now. It's only been 10 seconds, but we're good to go. And so what an idling resource does is you register with the Espresso system, and then basically what you're saying is, hey, wait for a little bit, and now, okay, you're good to go. So the most basic example of this is a counting idling resource, which you just increment and decrement. So if you're at 0, it means go ahead. And if it's more than 0, then Espresso will wait for you. So the main thing I just want to preach, is never have thread.sleep. So never in an Espresso test should you have that. If you have it, it's a hack, and there's a better way around it using an idling resource. So I've seen this in a lot of code bases. I've also seen things where the tests are not set up to be deterministic, so they're waiting to see if they get there, and then they'll like check every second or 2 seconds, and then see if it's there. But you're not leveraging everything Espresso can do if you're doing that. So the way this works is we talked about the view matchers, which is grabbing that one element on the UI that you're interested in. So you've created this interaction, which is not doing anything yet, but it's describing that piece on the screen that you want to deal with. What happens then is you're waiting for the system to synchronize. So Espresso is waiting for the main thread, async tasks, message queue, and it will kind of keep waiting until all this is done. Once this is done, it can use that view matcher and find the view on the screen, and then it will go ahead and execute that interaction, whether it's performing an interaction or checking a view assertion. So, I mean, Espresso is super simple, right? You grab it, you check something, or you perform an action, and it's just waiting. But this is how it's really fast, and it's pretty easy to do your tests. It's really the configuration and stuff. What's up?
So, for example, if you have a service that downloads an image asynchronously,
yes.
How do you tell Espresso to wait until that image is downloaded?
So idling resources is that. Idling resources is the way that you contribute. So it's on the side there. You contribute to Espresso knowing whether it should check things or not. So you can write custom ones. Sometimes if you're using a library, then they'll have one provided for you. So it kind of just depends. All right, so configurations for success. You may or may not know that Espresso does not care about animation, or it cares about animations. I don't know, care or not care. What happens is, if you don't have animations off, Espresso will start checking things before it should, and it might cause your test to fail. So if you disable animations, which you can do through developer options, or if you write your own code to grant ADB commands and send a few commands via the command line, you can also do it for your continuous integration. But what it does is, because let's say your screen is coming up and it's sliding in, right? And that's a 1 second slide in for whatever reason. If you're trying to make sure that your view saying, welcome back Sam Edwards is actually shown there, it might be checking before it actually slides all the way in. So with Espresso, you turn it off because you just want to say, I'm now on the screen, is it there? And you can't really validate because you can't do animation. So Espresso is not aware of that. That's, I guess, a downfall, but it's also a perk because it goes faster.
Does Espresso work with hardware acceleration turned off?
I believe so. I'm not sure the answer to that question.
Because there's some views, like there's still hardware acceleration isn't supported for certain canvas operations and for certain things to get it to render correctly, you have to turn it off.
Gotcha.
And I was wondering if that would break Espresso.
I'm not exactly sure, but yeah, we can check that out. We actually don't have any canvas in our app, so that's something I'm not sure of, but I'm sure there's some Googleable results on that. Like I said, use idling resources for any background work you're doing that Espresso is not going to know about from the Android system. And like we do, utilize the async task thread pool if that's something you want to do. It does maybe change the behavior of your application, but for all of our OK HTTP networking requests, we send it. We give the executor with async tasks only for Espresso tests. If you want to learn more, there's awesome stuff on YouTube by developer advocate Wilczek and then Chuki Chan. They both have awesome stuff. There's also some courses on caster.io, but that's a paid for site, but it's got some good stuff. All right, so we've kind of talked about what Espresso is, why we're going to use it, but now let's talk about some of the things that we can do in the code to make this more maintainable. So we're going to talk about the robot testing pattern for Espresso tests. And this is kind of analogous to any sort of pattern that you're setting up, whether it's MVP, MVVM. All of these are set up so you have a separation of concerns. In this case, we have 5 tests along the bottom, and each one of these tests rely on interacting with the user interface. So what happens, though, is if I change one part of the screen, and just pretend my app is there, right? If I change one part of it, then every single one of my tests is going to break. So now I'm required to go in and update the code in each one of these, which is not very maintainable, especially as you get hundreds and hundreds of tests. So what you can do is introduce a logical layer of abstraction called a robot. That's just like how you have a presenter inside of your MVP. And so the goal of this is to allow you to have one point of failure. So all of your tests rely on the robot, which then interact with the UI. So if the UI changes, you update it in one spot and everything's happy again. So what's happening here is the test is describing what you want to test, and the robot knows how to do that on the screen. Jay Gordon did a talk similar to this, and he talked about how the robot's got kind of the thing holding the phone, right? So it's a person or a thing holding the phone. And the test itself is just somebody giving them commands over their shoulder, right? So the robot's sitting there, and I'm over here, and I say, I want you to enter the username, and I want you to enter password, and I want you to log in. Right? When you think about those things with Espresso, you have to go find the view, you have to do all these things, but to describe it at a high level is nice. And you could do this with like Gherkin or something like that, and it's used for Cucumber. I just prefer this like Java syntax that you'll see because it's very much like the code that I normally write. And you can use Kotlin, but haven't gone there yet with these. So what does a login robot look like? So for this scenario that you see kind of typing on the side, typing in Sam, password, remember me, and sign in. This is what our code would look like. So if you want to look in my test, this is all you'd see. And so it's just saying, hey, I have a login robot that I created, the username of Sam, the password of password, toggle remember me, and login. Like anyone here can read that and know exactly what this test is doing, where if we went ahead and actually looked at all the code, we'd have all this stuff here. So you could see all of that packed into one method, or if we abstract it out, we have a very readable way of dealing with it, and like we showed before, we have one place to update it. So this is that same line of code that was stacked nicely, but in one line here. So first we enter the username Sam, and so this method takes in a parameter of type string. So when I'm telling that person over their shoulder, I'm like, hey, it's Sam. That's the only thing it needs to know. It then knows I'm going to find the view with the ID username that's displayed, and then I'm going to go replace the text and close the soft keyboard. So this is stuff too that you might not think of, but like the little soft keyboard might pop up, and like when you're typing text, it's nice to be able to close that down. So these are all little things that you only have to deal with once if you do it inside of robots. And then just going through, you're entering a password, you're toggling the remember me, and you're logging in. But as you saw, like this is so much easier to read than something like this, and it's a lot more maintainable because you have that separation. So multi-screen tests, I know I've kind of preached so far that small and targeted tests are the best, and that's true. But you want a few that kind of exercise your whole app just for sanity, and so you get screenshots of your whole app. So we've already looked at the login robot example, and we've gone through that fully. But the next part of the sample app that I have is kind of like a shopping app where there's different categories on the home screen. then the categories themselves that show what items are there, and then finally a detail page. So here on the home robot, I'm just saying I want to go to category fruits. And what's nice about this is it's just going to go ahead and tap on that the fruit item in the recycler view. Now the thing that's important about this is we're telling them to click on the item fruits. If I said go click on position 0, what if I go change my logic later on that I end up sorting my list alphabetically or by the most popular item? If I do that, it's going to be something I have to go back and figure out what item that shows up in, and it's a lot more complex. We wanted to describe it the same way we describe when we talk to somebody over their shoulder. So this makes it a lot more easy to read, and then it just puts the burden on the robot itself knowing how to deal with that. Category robot, the same deal. I want to click on pineapple down here, so I'm saying, hey, just click on pineapple. And finally, I have my item robot, and I'm just going to click add to cart. So actually going back one. So what's important here is that you see there's a robot for each screen. And the reason that's important is because you want contextual actions. One example we have in our app is we have like an OK button, and then later on in another screen we have an OK button with an exclamation mark. And so if I want to just write robot.OK, that means two different things in two different scenarios. So by having everything encapsulated in this contextual robot, I know this OK button or whatever would be in the login screen. And by having each one separated, it just allows it to be more simple, right? Because I know I'm dealing with this screen. There's only a few elements here. What are my actions I can actually perform on the screen? Because otherwise, if it's all in one blob, then it's a hard time figuring out which method you actually want to call.
Do you have a separate robot for the action bar items, or how does that work?
So the action bar items, typically the behavior that's like inside of, let's say here we had this action bar, right? In the home robot itself, I have the ability to click on the cart icon and stuff like that.
So you have to copy that over into each of your robots.
So it depends on how you want to do it, right? Because with Java, you can have a helper class, and then you just maybe use a class hierarchy to go ahead and extend it out, and they all have the same method if they deal with that. Or there's a lot of ways of abstracting that. Like you even saw back on that one example where it's going through enter username and enter password. It's the same thing on each one. It's like find the ID, you put this text in. So we're all good developers. You make a method that does a helper for that, but it's still abstracted out from the robot way. Was there one other question?
Yeah, we were talking about a realistic example where someone is using the phone as a robot.
Yeah, sure.
And what if you would write a robot that gets a context something, which just like one robot knows where it is and what it can do on that specific context? Would that be better, or is that even possible?
Do you mean the Android context, or?
No, not specifically the Android context. Just give it a name or whatever screen it's on at the moment, and then it knows its actions.
So you could do that. The reason why I've done these, broken them up in their own classes, is because I wanted to use the builder pattern. And so it's like a really nice syntax to just say ... And you could have it all in one thing and say, I'm interested in this, like just in the login actions right now, and go with that. But anyway, I've just found this to be a really clean way of doing it. So it's just a personal decision, but that's another way you could do it. So screenshots now, as you saw, I think are really important, and they are the icing on the cake. It's the way that you sell this to people. We'll go into that. But the only thing you need to do is in your robot implementation, and this is the stripped out version of entering the username, you just add in a take screenshot and enter username. So what's going to happen is it's going to take a screenshot titled enter username. I know this is a little bit magic. In the library Spoon and Falcon, we'll kind of show a little bit later, this can do it for you as long as it's called from a test. Basically, if you're in your test, you're calling some robot, which is taking the screenshot. When you take that screenshot, it'll traverse the stack trace and then figure out what test it was run from, and then be able to figure that out in the test reports. So the syntax really is this easy. So add that in everywhere. And then the same thing with the login robot. The only thing that's different here is I'm actually saying logging in a future tense. And the reason why I'm doing this is because when I click on this, it'll go to another activity. I know it changes the state of the screen entirely. And so if I don't take it before I click login, the click will happen, and then we'll try to take the screenshot immediately after. The screenshots aren't aware at all of idling resources or waiting for things. So it might get that animation or just a weird transition, and it won't actually get a screenshot of what I'm doing here. The goal of these screenshots, at least in my scenario, is to so when you look at this flow like a storyboard, you want to see what things are happening. And I wouldn't have something for logging in if I didn't take the screenshot before. This way I know I'm logging in now.
What if I wanted to test tabbing from one text field to another? Most of these examples are specifically finding a view and entering something in. What if I say supposed to start in this field, enter something, tab, enter something, and it should go from one field to the how would I do that?
I haven't done that, but that's great. Like Espresso's great for usability or accessibility testing. That could be part of that. I'm not exactly sure, but like just with this pattern, you can see a way to abstract that out, so it's a little bit cleaner. Oh, sorry. So I got 3 reasons why you should take screenshots. Kind of building up a little bit. But first of all, you want to see what's being tested. And the thing I like to show off here is, let's say that you just joined my team. All right, so welcome on. This is great. Go ahead and run our test suite. Awesome, you ran it. Great. Now you know that our test passed. That's very important. But you know, you can't really tell what all the tests were. It sounds like there's like 150 of them. That's great. But I don't really know what happened. So I can go ahead and run Android Studio, and then I get a little bit nicer output where it shows me the package and the name of it. But you know, test home screen overflow menus. Okay, what do they look like? I don't really know. So then we could just do an HTML report using Spoon, and it's not much better because we don't have screenshots. But if we add screenshots in, then in each one of those test results, we actually see the full flow. Now, this is against my advice of making small targeted tests. This goes through most of the app. But this is the example of that one smoke test that you want to go through and just make sure everything's there. But it's very easy to see now. We have a welcome screen. We log in. We have different setup configuration options. We're going to different things. And when I look at this, or when the new person joins their team and looks at it, I can see exactly what this app is doing. So you can see what's being tested. Number 2 reason is because if anybody's written Espresso, you see this. And this is a dump of the view hierarchy. So it's a text representation with like 1 plus, like a plus dash, and a plus dash dash, which kind of is showing that view hierarchy that we saw before. But it's really, really hard to read, and it's really hard. So you could go through here and just figure out that like no views in the hierarchy found with text done in capital letters. But if I take a screenshot of that point of failure, I can see that, oh, for some reason somebody changed the text from capital D to, or all capitals to, you know, just a capital and then lowercase. So it's great to have this because you have all the data you need, but you don't have the context of what that actually looked like on the screen when it failed. So if you want this to happen anytime an Espresso assertion fails, then what you can do, so this is what it would look like in your test report, where it would say, hey, this failed, and here's your screenshot. So the way that you would do this is Espresso has a failure handler that you can set. As you can see, it's just a public static method, but you send in a failure handler and you set it for Espresso. By default, it's going to use the default failure handler, which will just kind of crash your test, and then print out that view hierarchy. What you can do is add your own here, where you're saying take screenshot forcefully. And this is my own method I have. And the reason why I have to say forcefully is because I don't always take screenshots when I run my tests. It is a lot of overhead, but there's value of doing it in certain points of time. And so when I say take it forcefully, that means, like on that last page, you don't take any screenshots unless something fails, because you just want to see all the greens there. If something fails, though, like in CI, I just want to see what failed. And then finally, we want to go ahead and throw our default failure handler right after that, because if we don't, then it won't show the view hierarchy to have that as well. The last thing, which is the most important, if you just come out of here and this is like your one seller of getting your bosses to allow you to do Espresso tests, is to share it. Because right now, no one cares, and no one sees the value of your Espresso test yet. So this is all the people that pay you, right? Your bosses, maybe your product owners, designers, manual testers, all these people don't care. And that's because to them, it's just console output, just like the new person that joined your team. So let everyone see what's being tested, right? So if everyone can see what's being tested, then everybody finds value in what you're doing and can support you going through with that. User interfaces are visual, right? The reason why we're seeing value out of this from anyone is because our app can be used by anyone. And if we want anyone to see the value of our tests, they want to be able to see what's happening as well. And there are ways to do videos like MP4 recordings, like Firebase Test Lab does that as well. But I like to see the whole storyboard. It tells me exactly what I'm seeing. I can scan through real quickly. So yeah, our user interface is very hard to represent in a non-visual way. We saw what the failure stack trace or whatever looked like when an Espresso test fails, and it's really hard to tell. So imagine that you had to describe to someone who's visually impaired what the Mona Lisa looks like, right? I don't even know how to start. Like, I could describe the colors. I could describe the view hierarchy, where there's, you know, her face is put in the middle and so forth. But it's really hard to describe this in words so that somebody else can understand and see exactly what you see. So pictures are very good. I did a talk at DroidCon last year in New York City. If you go to my site, there's a link to the video, but I really go deep into screenshots. So Espresso, a screenshot is worth 1,000 words. So this is just a bonus, right? We've talked about all these screenshots, but you know you can run espresso tests on any device. So you can run it on this small device, you can run it on this huge tablet, and they both work. Now I can get screenshots of all my tests running through both of those. Now granted, I might have to do a few tweaks to make sure it scrolls on the small device versus a larger device or whatever, but that's a little investment to make people do this on all your devices. And we all love Android fragmentation, or we all hate it. It's great because we have now some crazy, over 50% of adoption throughout the world is, people use Android devices. But that includes different device sizes, small, medium, large, different OS versions, and this doesn't even show O yet, and we don't even know what that means. Samsung's, HTC's, Motorola, and then you have Japanese, English, Finnish, anything else. So you have all these different combinations that you could run your test suite on, right? So I could say this time, run my test suite on a small device, running KitKat on a Samsung with Finnish on there, right? So you can actually see what that looks like, where normally you'd have to do all these, do a lot more. So test reports are really important. I've been showing Spoon, and this is the testing report framework I like, because otherwise, if you do save screenshots, you don't actually see them if you run them through Android Studio. Now I'll actually show you the process that it goes through here and why you don't see them. And so also for each test that you run, you get isolated logs. So normally if you ran all 150 of your tests or whatever you had, you just see all this console output. Where in Spoon, if you click on this little icon next to your test run, it'll just be from when that test started to the test ended, all of my logcat. So Spoon is a library by Square that's kind of outdated, honestly. I think they're doing some work on it now to create like a new version. But I don't know what the timelines are for that, probably a year at least or so. But right now, it's the one that we found is the best, and we like it a lot. Not only does it have these visual reports, but because instead of you running the instrumentation running yourself, you're having Spoon run that for you, so we can like start everything, copy all the screenshots off on the end, capture the logcat. You have to interact then with Spoon, and then it interacts with the instrumentation runner. So you give Spoon your APK and your test APK, and then it goes off and runs those. So it would run on every connected device you have to that machine right now, and it would run all of your tests. But you can specify what package you wanted, if you wanted to run across multiple devices and so forth. You have that ability, and in the documentation it shows how. So this is what a Spoon report looks like if you run on 2 devices. In this case, it was 70 tests that were run on each device. This was a small emulator that I programmatically generated, and this was a larger tablet device. And now you can see this one highlighted here, but each one of these little sections, they'd all highlight as you hovered over them, represents one test that was run. And so, and this would be red if it actually failed, but of course everything's always green, right? And then if you actually clicked into that, a specific test, like that login test or the smoke test, what we actually see here is side by side, or not side by side, top and bottom. This is the small device, and so all the screen flows. It's really hard to see for you guys, even for me, but then all of the screen flows for the large device. So we can see that. So you can have 2 different ways of looking at your screenshots. So this is the process of how screenshots actually work. So first you traverse the view hierarchy, and that's usually done with a library like Spoon or Falcon or UI Automator. And then that's saved to a specific location on the device. So it's actually saved to the SD card or the internal storage of that Android device. And then at the end of the test run, Spoon would, or some other test report runner would actually do an ADB poll, where it's doing this pulling those images off the device and copying it to the local system. And then what it will do is it will scan the local system to say, what are all the files here? And all the files should be in a directory structure that it's aware of. So it would be like package name / class name / method name, and then like a timestamp or something. And based on all those, it can then generate a report because it knows all these screenshots were from this test and like what order they were based on timestamps. I think I name dropped these a few times, but I haven't showed why they're different or what they are. So Spoon itself has a companion library that you can use in your app for taking screenshots. And this is all the exact same screen, but there's a few differences. So Spoon is not going to give you anything, any virtual buttons, nothing in the title bar, and it won't show you these overflow menus too. However, if you use Falcon, it will capture overflow menus, it will capture alert dialogues and anything that's at a system UI level. And if you use UI Automator, you also get the system bar as well as the bottom virtual buttons. And so just long and short, and you can see that Espresso talk that I talked about is screenshots worth 1,000 words, but the long and short is we chose Falcon. And that's because we don't really care what the state of is outside of our application. We care about what's happening on the inside. And the performance impact is this is way faster than UI Automator. Plus, UI Automator only works on API 18+, but it is provided by Google. Other screenshot libraries you could use could be Firebase Test Lab. They use a screenshotter. And so that's really just saving it in a different directory. It's really using the underlying implementation of what Spoon has and what UI Automator has. And the same with Fastlane. I talked with some of their devs, and they're using something similar to Spoon on lower devices, and then on newer devices, they're using the UI Automator screenshots. But they're just saving in different directory structures. And that's just because Firebase Test Labs wants to show them in their UI appropriately. Fastlane has a way with screen grab to like run some tests and take screenshots. So this is very controversial, but should you use devices or emulators? The answer is emulator for all development and continuous integration. I'm sure somebody in here will disagree with that. That's okay. Let me explain why I think that's the case here in a sec. But my recommendation is to use devices only for release regressions. Once like your code locked and you want to test on a bunch of devices. And here's my case. So use the Android emulator because you're running real versions of Android. This is an emulator. It's not a simulator, so you're actually running real Android. It's configurable. So that means you can start it with a small screen res, high screen res, like kind of create any kind of device you want. It's faster than a real device. So the Android emulator now can run on x86, which is your native architecture you have on your computer. And so what's nice about that is you can get all the processing power you have out of your computer. All right, this is a long talk. I'm just going to sit down for a second. You can get all the processing power you get out of your computer, but then you don't have to run it on your real device. So it's a little bit faster that way. It's available on demand and scalable. So in continuous integration that you have, you can go ahead and run as much of this as you possibly want. And it's cheaper and lower maintenance because you don't have to buy all these devices and have them ready and available. Also, like for screenshots, what I recommend is running on low density MDPI devices. I recommend this because every screenshot you take is a large footprint, right? You usually think it's like a meg, but if you do it on a really low density device, it'll actually be like 30K. So you can take a lot of them and it's not a big deal. All right, what time are we at here? All right, go ahead. All right, so shared state. This is a challenge that you have with an maintainable Espresso test suite. It's a challenge because when you run one test, and let's say you click the Remember Me checkbox, the next time you run a test, the Remember Me checkbox will still be checked. And the reason that is, because the app launches once, but then the tests all run back to back to back without restarting the app. This is a version of Whack-A-Mole. I don't know if you guys have played that game in an arcade before, but what it is things keep popping up, and then your job is to like keep knocking them down. And really, this is what you're doing when you're combating a shared test state problems. So first of all, one thing you want to do is clear preferences. So every test run, you want to clear all of your preferences so they're not lingering over, like the Remember Me or something. You want to clear all your databases because anything left on the device is going to affect the next run. You want to clear all your files. So if you're saving something to this disk, you want to save that because otherwise your next test runs and all these things are still sitting there. And so it's not a fresh, it can't for sure know that I'm passing or failing based on what's in my test. You want to reset all your singletons and static variables because those are still in memory. And if you use dependency injection like Dagger, which is highly recommended, you can re-inject everything and basically get a new instance of things, depending on how you implement that. And finally, you want to kill any background work. So everybody has to have a kitten picture in their presentation. And so this is his version of Whack-A-Mole, but you can really see yourself doing this, right? So as you're coding these tests, every single time you have your setup method that you're running your next Espresso test, you're literally going, oh no, did I leave a preference out there? Is that going to mess up my next test? Do I have a database? Do I have any of this other stuff? And so you really have to go through this, and it's a really, really big problem. Right now, I play this game on a daily basis. And I'll show you why I play that, but why there's hope out there. Luckily, this is actually working for us at the moment, but I'm just a really fast cat, I guess. So now, in order to really understand how we're going to solve that problem of the kitten trying to knock down fingers is understanding how AndroidJUnitRunner works. So AndroidJUnitRunner is a layer on top of Android instrumentation that allows you to run like JUnit syntax. Otherwise, you have to use some other syntax that they have. The more you know, the better. So what happens here is you're running your ADB shell instrumentation command. So this is what you're doing if you're not running something like Spoon, because Spoon will do that for you. It basically goes up and starts a framework with the activity manager and creates your application and it creates your instrumentation APK as well, or invokes it. Then the AndroidJUnitRunner's job is to go through and execute all those tests in a row, just like I kind of showed in my example. But they go back to back to back to back, and you have no clearing of data or state or anything in between. So this is why we run into those problems and why we're going to have issues with maintainability. At the very end, though, we get our report, which just spits out, 30 out of 40 passed, and then we're done. It comes back to the command line. So the way that we solve the problem of the kitten knocking things down, I'll just call it whack-a-mole, is isolated test execution. So this means every single test starts the app, runs, completely shuts everything down, clears the device, and then goes on to the next one. And this is possible right now, but it's really hard. It requires a lot of custom scripting. So the way this will work is, you run your test, and then you'd run an ADB command to say, clear this package, which is the same as going to your settings screen and saying clear data. So it's basically an uninstall, reinstall, but without having to pull the APK on and off the device. The way this works then is you would just literally run the instrumentation command for one method. So you're saying, in this one test, I want you to run this one method, and then it would shut down and clear. And then you want to do that again. So you literally have to write a shell script that will run instrumentation for each method over and over. So that's going to be a lot of work. To actually achieve this, Drew Hene, who works at LinkedIn, he's been one of my resources that I reach out to a lot. They have some really great test automation there. And I'll do my selling point now. He's speaking at the Android Summit. It's happening in about a month. You guys should check it out. It's just here in McLean, or Tyson's Corner. But you can talk to us later afterwards. It's pretty cheap too. But yeah, LinkedIn has released this testing library called the Dex Test Parser. And the goal of this is to run via the command line. You pass it a test instrumentation APK. And what it will do is it'll actually parse the Dex and determine all the methods that are in there. Because otherwise, you have to think about it you'd have to know ahead of time all the test methods that are in your test APK before you started running this loop. With this way, you can kind of just ask in what are all the methods dynamically, and then it will give you a full list of all my test methods, and then I can do that looping. Right? I can run each one of these commands one by one by one. So it makes it possible. But that's a pain. They do this, and they do a good job of it. I'm not there yet, so I'm still playing whack-a-mole. But it executes each test method individually, and at the end, you have to combine the test results, which it doesn't do by itself. You'd have one JUnit XML file, and then you have another one. Each one would be for one test. And what stinks is you can't really use Spoon on this, right? If you use Spoon, you'd have one test report for the one test, and you'd have another one. So it would take a lot of work to really dive in and see what's happening there. So you need a bunch of custom scripts, and this won't work on Firebase Test Lab. So that's something that people use for cloud testing, and it's really not going to work too well in there, or not going to work. Welcome, the Android Test Orchestrator. It was announced at Google I/O 2017, and I'm drooling over it. It sounds awesome. It's going to be available in the next version of the testing support library. I have reached out to their team asking for dates. Basically, this year is the best I got. I couldn't get a preview. I told them I was doing this, but they wouldn't give me a preview. But anyway, they released a lot of information at Google I/O, so I'm going to show some slides from there kind of showing what's happening. But what it does is achieve everything we were talking about. It achieves the clearing the complete state between every test run, and it does that for us. And the way it's going to do that is by installing an additional APK. So there's our APK, the test APK, and then this extra service APK called the Orchestrator. And what's nice is you'll be able to have all this custom scripting is required now, and you can't just hit play in Android Studio and have it run 20 tests in a row and have this sort of hermetic testing environment, where with the Orchestrator, you can just hit play and it'll do it for you. Oh. So here it is. And what is happening is it's going to install your application under test, your actual app, your test APK, and then the Orchestrator itself. And so what's happening now is the Orchestrator is actually running its own process. And this is important because right now, all of your tests run in this process. And if it fails or it crashes, that means all of your subsequent tests won't run because they all run back to back to back. Where now, because everything's is orchestrated by this, then it's able to say, go ahead and do one test, and then it's done. And if it crashes, it's completely separate, right? It just can continue on. And what's also nice is because it's orchestrating this outside, it can run that package manager clear command between each time. And so you have a completely clean slate. So this is huge. If you think about right now, if you went ahead and write your test, with Espresso Test Recorder, and you said, remember me, and then you want to make sure that was unchecked. You literally have to have something that said, if this is here, do this, and if this isn't here, do this. And that's another thing I highly recommend against. You want your tests to be completely deterministic. So when I do this, this happens. And the only way you can do that is by getting all of these things out of our way, whether it's like the data setup we have or the test execution environment setup, where we know we're going to have a clean slate. So the way it works now is we run the same instrumentation commands we would have run on our test APK, but now we run it on the orchestrator, and then that does it for us. So this is like pretty game changing, and I think everybody's going to find it's a lot easier to have maintainable Espresso tests as soon as this comes out. Otherwise, we'll be writing all those custom scripts, which I've avoided at this point, but it works. So this is just the example of all the orchestrator running each test individually and being done. So the benefit now is of using the orchestrator is there's no shared state, there's isolated crashes and isolated debugging. And so we talked about shared state a lot, the crashes we talked about, but isolated debugging is very important because if the second test always fails, is it because that's bad? Or is it because I had the first test run first and then this one? And what's really hard is when you're running your tests in continuous integration and something's failing, how do you replicate that on your own machine? How do you see that 2 tests before I actually set this variable, it's a static variable, and I figure that out, right? So this is big. So I also talked about small targeted tests. And the reason was that like testing pyramid, we want something to be as fast as possible and as cheap as possible. And if we have small targeted tests, we're really running on that line of integration tests. And so we are UI tests, but we're very performant, right? So we're top of our class or bottom of our pyramid or whatever you want to call it. So you guys have probably seen activity test rule. If you haven't, you'll see it when you use Espresso test recorder because it'll generate it for you. But it's a JUnit4 test rule that you basically say, hey, I want you to launch this activity. So it could be your splash screen activity, your home screen activity. It could be your settings activity. But you're just telling the same way you could do via the command line, open this activity with this intent. And so that allows you to set up your app so that you can go directly into this one place. And as I said earlier, you need to mock out a lot of other things so that if you're jumping deep in your app, your application's in a state where it's going to be able to handle that. And the whole reasoning, if your login page breaks, then when you're going through, you'll never get to that part of your app that you actually want to test. You need one just for your login page, and then you'll be happier. And you might have the argument, well, the user's always going to go through there. But when you really think about it, everything has a barrier, whether it's an intent that goes between things or the inputs that go within to your app. You want to completely isolate it the way you do a unit test, and that way you can figure out what's actually failing, not just like it fails in this process. So you want to isolate it and have the expected inputs, and then you can know whether it's passing or not. So skip to the important part. That's pretty much what I'm saying is if you're testing settings screen, just skip there. Just jump directly there and set up the state without going through UI. It's like one thing that's hard for people to realize sometimes I think is like, if I want to test something on the home screen, and I'm just thinking about it from an outside perspective, I always have to launch the app. I always have to username, password, get in there, and go to that screen. Well, if I think about it, what's really happening is when I click that button, I'm sending in a networking request that goes out, comes back with my user account. I then set that in some repository or DAO or whatever else I'm using, or session manager. And then what I do is when I get to the home screen, I'm checking the session manager to say, oh, who's logged in now? So all I have to really do is, instead of going through that whole UI, I do all the actions that are actually happening through that process. And I can generate that networking request myself if I wanted to. I can also just fake the session manager and say, hey, this person's logged in. There's a lot of ways and strategies of doing that, but it's your job to set up that state without going through UI, because then it's a lot faster. So Hermetic and Deterministic tests. I've had my own struggles defining what those are, but I think I finally understand. So I don't have a good slide, so I'm just going to project out what that means. So Hermetic means it's really those isolated test execution environments where your test is not affected by any outside sources, right? So it's not those shared preferences from the time before. It's nothing left over from my last test run. And deterministic purely means I'm giving you mock data in my test so that you should produce the same results every time. So you want to mock everything external to what you're testing, and that's kind of both of these combined. And what we do is we actually mock all of our API requests. And so we do a lot of server requests. We're a banking app, so we don't store much on the device. We have to call out to the network every single time. So we mock all those out, though, by generating the Java objects on the device, serializing those into JSON, and programming in a local web server running on that device. We use WireMock. There's pros and cons to it. There's also mock web server and REST mock, which is a layer on top of mock web server. And you could also use something like Mockito, or you can just go super simple and just say, I created this object, throw it into my session manager. Another strategy you can use for mocking your API requests is literally just having JSON files sitting on your system that you can serve up. And sometimes that's easier than generating them yourself. But as you get to a really large scale of tests, and I think now we have almost 200, or even more than that. As you get more and more of them, you'll realize that if you have to go update JSON files yourself, it's a pain in the butt. Like, you need to like generate the Java object that generates the JSON, and then have a test to make sure that contract is adhered. Because you think about with your API contract you already have with your server, it should be in an exact format. And as long as you can generate that JSON the same way they can generate the JSON, then it should be good to go. So this is a good visualization of what Hermetic testing kind of is. And the fact of not only is it that isolated test execution environment, but it's any external forces that may come in and affect the way that your app performs. So in this case, if your app responds to like a Wi-Fi was detected, right? In this case, then your app would behave in a certain way where for some reason it detects Wi-Fi and now it pops up some screen. So you want to completely cut that off. Same with anything else, whether it's camera, where anything external coming in, you want to like hermetically seal that off. I know hermetically sealed, at least what I always thought of it was if you had like a plastic bag or packaging that came out of a factory that was sealed, it would hermetically seal against there to make sure that nothing got in there. So intent boundaries as well, like I've been talking about how you want it to be small and targeted. And sometimes what you need to do though is say like, oh, start this activity for a result, and then when it comes back, then I want to do something. So how would you actually test that if you're in this one activity and you're expecting this result to come back, even from a third party or another activity you have, but that one you don't want to deal with? You really just want to say, here's my activity result, go do something now. So you're mocking in what the activity result is, and you can do that by basically saying, if the intent going out is this, then respond with this activity result. And then with Espresso Intents, you don't actually have to go and run that next activity. You just kind of get a fake one back. And so it's nice because, yeah, instead of having to launch a second screen or deal with anything that goes up to the network, you're literally just returning your activity result, and you're good to go.
To give you some false results, because like on pause is going to get called if you actually run the activity, whereas this looks like it wouldn't get called.
I'm not sure the best answer to that. I haven't run into that. But like in the cases I'm running, I'm not usually doing the on pause, on resume sort of scenarios, because then it gets out of, you'd have to manually invoke those lifecycle actions within your test, or you'd have to actually like close down your test and open it. And Espresso is only running within the scope of your app. If you want to like actually hit home system buttons and things like that, you have to use UI Automator and some other frameworks. So I see what you're saying. The way that I write tests, I typically don't run into that. But that's a really good point, though. You have a lot of edge cases where problems really come with the user going like and hitting the home button and then going back to it, and like life cycle issues. And there's probably ways to do that with Espresso, but the ways that I've been using it is mostly just validating my UI's work, the flows work if you're within the app. And then a lot of manual testing really is valuable still because it's going to find stuff like that. And there's probably better solutions than my little tip there.
Yeah, I was going to say maybe you're augmenting these Espresso tests with other tests because maybe that intent for result, maybe it went out to a third party, you're making a post to Facebook in your app or something, and maybe Facebook changed at the other end, so you still need other tests.
Absolutely.
This won't catch that, so I think you have to do it somewhere else.
And I think that's just like the testing pyramid in general, right? Like each level of the pyramid should be aware of the inputs and the outputs, and so you keep building upon that. And then at the very top would be Facebook that you rely on, and you want to do that end-to-end test, but you can, if you expect this to come back from Facebook or whatever, then you should be good to go. So like driving in continuous integration. So one thing that's really important with maintainable tests is that they run all the time. Because if they don't run all the time and they don't run consistently, you won't know whether they're kept up to date. And one thing that I hate is when I see the developers say, okay, cool, we finished this, let's go ahead and merge it, we make a build, and they're like, yo, QA, here's our APK. And then like they're over there testing it, there's a problem, I've already made a new branch, I'm working on new feature work, and really I broke something I should be responsible for, right? Like I changed the layout file that affected something else. Now they're having to write a bug, come back to me. Where if I'm running everything in CI all the time and every PR, I can see I broke it and like I have responsibility for that now. So as a developer, I should be writing tests, I should be responsible for that. We shouldn't be throwing it over the fence or across the room to our QA people. So let's run it on every PR if we can. If not, let's run a subset. And then once that gets merged in, let's run all of them. And it depends. If you get thousands of thousands, like one of our apps has, our main servicing app, you may have to run it like just 2-3 times a day. But run it as much as you possibly can, and at least run the tests that your code changes. And if, like, a lot of you are probably like, well, where do I start? What we do right now, what we started with was a local test machine. So I literally had a Mac Mini sitting next to me. I have 3 executors on it, meaning it can run 3 emulators at a time. Our Jenkins job basically throws down like the APK that I want to run. I'll run all the tests, I'll take all the screenshots, and then it'll go up to our main Jenkins instance. So that can work. You can even do that where you go off and you run your tests on Firebase Test Lab, Amazon Device Farm, Circle CI, Buddy Build. Out of these last ones, the only one I've tried is Buddy Build, and it was really easy. So I don't, if you want to run your tests on the cloud, I basically just said run and it worked. I've never had such an easy experience. So I'm not selling them. Yeah, it was easy. So I was surprised. And yeah, Firebase Test Lab for Android is really, I think, the one that's going to come out as a shining star because it is Google supported and they have a lot of good stuff happening there. When we talk about speed, when you get those test suites that end up taking 2 hours, 3 hours, 6 hours, 8 hours to run, what you have to do is parallelization. So what that's going to mean is like you can split up everything the same way that I have everybody in the room here. And if you all did one thing for me, then I wouldn't have to go do it this many times. So we could achieve that in, if it would take me, I don't know, 100 times to do this, we could do it in one time unit if we all did one. And so that's what this is doing, and that's what sharding is, which is part of the Android instrumentation runner. And so what happens is you basically say, here are the number of shards, which are the number of separated out groups, that are always going to be the same for that test APK. So it's always going to split it exactly the same way by doing it like either alphabetically or however it does it, right? So you say, here's the number of shards, and then you're shard 1. So the same way if I went around here and said, we have 100 people, you're number 1, 2, 3, 4, and so you know to only run that one test, and at the end we combine our results, we know we've run the full test suite. And you might say like, well, that's hard because what if this one's running on the Samsung and that one's running on whatever else? If you do the emulators, they're all the exact same emulator, and then you're good to go. So that's our solution right now. Some words of wisdom. I really look up to Don Felker. He's a really good Android developer. And he says, unit tests and integration tests are the anti-anxiety medicine for developers. More of the story is to write more apps and ship higher quality apps. And I think this is absolutely true. I think when you go home after shipping a release, if you had all your test screen and you know you have hundreds, or you're doing a refactor, you're not like awake at night going like, did I change that? Like, what's going on? Like, you really feel a lot more confident about what you're doing, and when you go home, you can cut off because, as we all know, there's so many things to learn in Android. I got to learn Kotlin, I got to learn RX, I got to learn all these things. One less thing to worry about is great, and then you get all these other benefits out of maintainable Espresso tests. Well, yeah, thank you. Cool. And then let's see if we have. I guess it's full time right now. So anybody that wants to leave can leave. I might have to have the other person set up that's next. I don't know if we have a break or not. But feel free if you have questions, just come up and talk to me, and I'll be happy to keep answering. Thank you.